Okay, this is another one of your classic displacement reaction with the metals. You have this wonderful black powder, which is copper to oxide, which is really opaque, obviously absorbs a lot of light and doesn't reflect very much. And what we do is we mix it with zinc metal in powdered form. And this is quite a gratifying little activity. You kind of mix these together. You go from black and grey to a kind of darker grey colour. What you need obviously is an intimate mixture to get out any lumps so that when these start to react, the reaction can perpetuate. Again, it's one of those reactions that needs a bit of a kickstart of energy to overcome the activation energy, but once it starts, it just keeps going. So it's two reactants in solid form, and what's going to happen is the zinc is going to kick the copper out of its compound. So I've formed this into a fine line so that the reaction, a little bit like gunpowder, the reaction can move through the mixture. So once the reaction starts, you give it a kickstart with your blowtorch. Once it starts quite slowly. The heat builds up and it moves along the line. Obviously a very exothermic process, and you'll see there's some lovely colours, greens and blues, which are due to the copper. You can see these colours really coming out as it burns and gets hotter. So it moves along the line and it does really look a lot like gunpowder in the classic old films. Gradually moves along. Now this is where you do need a decent fume cupboard, because it does produce a lot of powder and smoke. I imagine that's zinc oxide that's being thrown up into the fume cupboard. Luckily we have a fume cupboard that really does extract these gases well, and it's carefully designed so that all of the smoke and fumes go directly up into the French department. So it's win-win really. Lovely flame and beautiful colours. Now zinc oxide has this property, you won't be able to see it I think here, it has a property of being yellow when it's hot, but as it cools it's white. It's a physical property. So as the temperature changes, the colour of the oxide changes. And that's it, it's dying down now. So we're left with copper and zinc oxide.